Well, we're finally finished with all of our area formulas, but now we got to talk about how area relates to similar figures. So first of all, the things we know about similar figures is that their angles are congruent and that the sides are proportional. Proportional. So basically I can set up a proportion between the sides. And just remember that all similar figures have a scale factor, and in this case we call it K. So let's just make up a scale factor for this guy. I'm going to call K 3. Okay, so I'm going to plug in a 3 for K here and a 3 for K here. Which 5 times 3 gives me 15. So this side length is going to be 15. And 9 times 3 gives me 27. So this side length is 27. So when I say that sides are proportional, I'm just saying the corresponding sides. So 5 corresponds to 15. Right, 5 corresponds to 15, and I could set that equal to, well, go back to your original rectangle, 9 corresponds to 27. So those would be equal. Those ratios would be equal. That's why they are proportional, we say. I could simplify them both into 1/3, or I could take the cross product and see, and they both work out. So that's what we know about similar figures. And we've talked before, I'm sure some of you remember, that perimeters are actually proportional as well. With our similar figures. So let's look at that here quick. So I got 9 and 5 for the rest of these sides, which gives this a perimeter of, well, 10 and 18 gives us 28. And then looking over here, we would have a perimeter of, well, let's see, this top is 27, this side is 15. So the perimeter here would be, well, 30 and 54 for 84. And if I take a look, perimeters are actually also proportional to the sides. So for example, I could just take any ratio of sides. And usually what we do is we always take the new side over the old side. Okay, new over the old. Because that also will give us our scale factor when we do the new over the old. So in this case, I'm going to take 15 over 5 because they correspond. Right, if I simplify that, I get 3. That's the scale factor. And I'm going to set that equal to, well, the perimeter of the new over the perimeter of the old. And they work out. I could take the cross product, or I could simplify both, and both would get 3, right? Because 28 goes into 84 3 times. So both of these would simplify into 3 over 1. Okay, so perimeters are also proportional. So if I had the perimeter of one of the shapes, and I didn't know the perimeter of the new shape, all I would have to do is multiply by the scale factor times 3, and I would get the new perimeter. It's pretty straightforward. So sides and perimeters work out the same. But areas are a little bit different now. Areas are a little bit different. Because if you think about it, with our units even, like if I was in centimeters, it's centimeters squared for area. So that changes things up a little bit. So let's take a look here at how that works. Well, let's find the area of this first guy. So it's a rectangle, so length times width. So the area would be 9 times 5, which is 45 units squared. And the area of my second guy is 15 times 27, which gives us 405 units squared. So I'm not just multiplying by the scale factor to get my new area. Right? I just can't take it times 3. So what would I take it times? Well, let's think about this for a second. Here's what our new rule is, how this works. Well, what is our scale factor here? It's 3, right? And I can find that by taking one of the new sides, putting it over one of the old sides that correspond, so 15 over 5. And I'm going to set that equal to my new area over my old area. Well, obviously that doesn't match up. Those aren't proportional. But I could do something to my scale factor so it matches up and makes it proportional. What I would do is that I would square the scale factor. Square that ratio of sides, and then it works out. Then it makes them proportional. Because if I take 15 squared, I get 225, and 5 squared, which is 25. And I set that equal to 405 over 45. And if I would simplify both those, we find out that I would get 9 over 1, 9 over 1, and then they would be equal. So I'm really multiplying by 9. If I take the first area to get the second area, And to make it even make more sense, it's really the scale factor squared is how I get the new area. I take the scale factor squared and then multiply. That's how that works out. So there's two ways to do this. Right? I can come up with a proportion, take the scale factor squared, and then set it equal to the area over the area, depending on how you get it set up. Or if I know the area of one shape, I just have to multiply by the scale factor squared to find the area of the new shape. It's kind of neat how that works out. And we have it nice and neatly written in here. So it says if two polygons are similar, then the areas are proportional to the square of the scale factor. So for example, right here, here's where the scale factor is. It's just putting the new side over the old side, right? New over the old. And in this case, FG corresponds to AB. So any new side over any old side. And then we square that, and we can set that to the equal to the area of the new shape over the area of the old shape. All right, let's look at an example. This will help us out a little bit. So these shapes are similar, and we know the area of the first shape is 48 square inches. And it wants us to find the area of the new shape. So let's deal with our proportion right away that we talked about. Well, let's set our scale factor squared right off the bat. So DC or CD matches up with what side on the other one? Well, if I can't remember, go back up and look. CD matches up with RS, right? The similarity statement will show that. And we always put the new one, so 9 over the old one, 6. So I'm going to go 9 over 6. And if I'm applying this to the area, I got to square it. Well, then we take the new area, which I don't know, so we'll just call it x for now. X over 48. And then I could solve. So let's go ahead and simplify. So 9 squared is 81. 6 squared is 36 equals x over 48. And then we just go through our cross product, so we're multiplying 48 times 81, which is 3888, and equals 36x. And divide by 36 on both sides, and x equals 108 inches squared for the new area. Okay? So that's one way to do it. The other way to do it is, well, what is our scale factor? New over the old, those sides correspond, which is really 3 over 2, which I can say is 1.5. And so to find the new area, we take the old area, and we multiply by the scale factor squared. So I'm going to take 1.5 squared, and then multiply it by the old area of 48. And I also get 108 inches squared. So both ways actually work out. Now I could use the same thing when I'm given two areas to try to find one of the missing sides of similar figures. So let's go ahead and write down some of our information. We got the area of ABC is 98 square inches. And we know the area of RTS is 50 square inches. So it's saying if they're similar, find the scale factor from ABC to RTS and the value of X. All right, so let's start setting this up. So it's saying ABC to RTS, so RTS is my new figure. So let's go ahead and use our sides right away. So new over the old, new over the old. I'll use blue for RTS. So new, which is X, over the old, which is 14. So there's my scale factor. And remember, I got to square it when I'm using area, setting a proportional area. And that's going to equal the new area, 50, over the old area of 98. All right, so there's a couple ways we can do this. We're trying to solve for X. So one of the ways is I can distribute that square right away. I can say X squared over 14 squared. That's one way to do it. Another way, which actually this makes it pretty quick, is usually what I try to do is anytime I have a fraction, I always simplify this guy. So for example, here I could cut both these in half, divide them both by 2. And if I would do that, I would get 25 over 49. Well, if you notice, both 25 and 49 are perfect squares. So if I wanted to get rid of this square on the left side, I could take the square root of both sides. So that would cancel the square, and I'd be left with x over 14 equals, well, the square root of 25, which is 5, and the square root of 49, which is 7. It's going back to our algebra rules, right? We can break up our square root. This is really square root of 25 over the square root of 49. And now that's much easier to solve. Way easier. Because I can take 14 times 5 and get 70. And then 7 times x, which is, x would be 10. Yeah, that was a lot easier. So now I know that over here, ST is 10 inches. X equals 10 inches. Well, our scale factor is just the new side over the old side. So for our scale factor, new side is 10 over 14, the old side, which is 5/7 for our scale factor. And lastly, you may not be given a picture, so now you just got to use what we've learned and apply it. So it says the area of one side of a skyscraper is 90,000 square feet. So I'm going to go ahead and write that down. Skyscraper, I'll just put sky, 90,000 square feet. Always helps me to write stuff down. The area of the corresponding side of a scale model. So the model has a 200 inches on one of the sides. So 200 inches. Oh, square inches. Oh, I see. So the area. I gotcha. Read that wrong. So corresponding area is 200 square inches. If the skyscraper is 720 feet tall, so going back to the skyscraper, 720 feet tall, how tall is the model? So how many inches tall is the model? So here we go. So we got area here and the height right below. So since I know, if I know corresponding sides and the areas, I can use that proportion where I square the scale factor. So it doesn't matter which one you use is new and old here. You just got to pick. So I'm going to use this side as the new, since old will be my model. That's fine. So if I take 720 over x for my scale factor, I got to square that, right? If I'm going to set it in comparison to my areas. And we're going to set that equal to, well, new, so 90,000 over 200. And like I said, start simplifying things. That makes it easier. So here, zeros cancel. So 900 over 2, so this is really 450. So I could rewrite this. I got 720 over x squared equals, well, 900 divided by 2 is 450. Well, in this case, I don't want to square root 450 because I'm going to get some decimal. So I'm going to go ahead and distribute my square here. So 720 squared and x squared. And 720 squared gives me 518,400 over x squared equals 450. So now we got to times by x squared on both sides to get out of the denominator. Times by x squared. So that cancels. Well, I got a mess here. Let me erase some of this stuff. I'm going to bring this guy over here. So what do I have left? I got 518,400 equals 450x squared. So to get the x squared by itself, divide by 450. Divide by 450. And we're left with 1152 equals x squared. And to solve for x, we got to take the square root. All of our algebra rules here. And the square root of 1152 gives us about 33.9. And we're looking at the heights of the model, so just inches. That's how one took a little bit of work. Just working with bigger numbers. That got a little bit sloppier. Otherwise, same type of thing. So remember, sides are proportional, perimeters are proportional to the sides, but the area, right, is proportional to the scale factor squared. That's kind of the neat little trick.